Hello friends, so today we'll study quicksort algorithm C code. So here is the quicksort function, void quicksort. To this quicksort function we'll pass an array, and that array will store in this variable a. Also we'll pass the left index of the array, that is where the array is starting, and the right index of the array where the array is ending. Before doing any sorting or any procedure, we'll check whether the array contains elements or not. Right? So that can be checked by simply checking the value of L and R. If L is less than R, then only there are some elements in the array and we need to sort them. So if L is less than R, we'll do the sorting procedure. So if you remember, in quicksort, the first step which we do is we choose one element as pivot and partition the array around that element, right? So here that partitioning job will be done by a separate procedure called as partition procedure. So I'll simply call that partition procedure here. To the partition procedure, I'll pass the array given to me, array A, which is starting at L and ending at R. So I'll ask the partition procedure to partition this array A for me, which is starting at L and ending at R. So this partition procedure will do the partitioning procedure which we saw, and it will return me the position of the pivot after partitioning. So I'll store that position of the pivot in the variable j, which we did not declare. So let's declare it. It's integer type variable. So then now I have the partition of the array such that there are lesser elements in the left part and greater element in the right part. So now I'll call the quicksort procedure on the left part. Same quicksort procedure I'll call on the left part of the array. Array is same, A. It is starting at L and the left part is ending at j minus 1. So this call, recursive call to the quicksort function, will give us left part sorted. Once we get the left part sorted, we'll sort the right part by using the second quicksort call. Right part is starting at j plus 1 and it is ending at R. So this call will give us the right part sorted, and that's where this quicksort procedure ends. Okay. So let me just summarize what we did. So quicksort is a function which does not return anything, so that's why the return type is void. So to this quicksort function we are passing the array to be sorted, the left index of the array and the right index of the array. So we are checking whether the left bound is less than right bound, right? That means there are more than one elements in this array. So then we partition this array by using a partitioning function. To that partition function we'll pass the same array A, which is starting at L and ending at R. So this partition function will partition the array for us, and it will return the partitioning point or the position of the pivot after partitioning. That we are storing in J. Right? So from left index L to j minus 1 will be our left part, and from j plus 1 to R will be our right part. So I'll call quicksort on the left part of the array, which is starting at L and ending at j minus 1, and we'll call the quicksort on the right part of the array, which is starting at j plus 1 and ending at R. So that's a very simple looking quicksort function, but the working is complicated as it is a recursive function. Thanks for watching. We'll continue with the partition function in the next lecture.